Hey everyone, it's Mrs. Shevchik, and today we are going to work through lesson 9.3, where we focus on area of composite figures. And we're going to be learning how to find areas of composite figures by decomposing the figures into known shapes, and then we're going to add the areas of those shapes together. Before you go any further with the video, please make sure that you have your textbook out and open to page 467. You have a pencil to write with and a calculator. Once you have all those things, push play. Page 467 describes what a composite figure is. And all it is a figure that's made up of two or more shapes. So to find the area of a composite figure, we have to decompose it into shapes with areas that we know how to find, and then find the sum of those areas. The first thing we're going to do, though, is make sure that we know all of our formulas for these very common shapes that we're going to be working with. So on page 467, I'm going to have you write this in with me. It asks us to label the shape with its correct name and the corresponding area formula. All right, so this first figure here is a parallelogram. And to find the area of a parallelogram, we say area equals base times the height. And the height always has to meet the base at a 90-degree angle. So this also works for rectangles, which you could sketch in on the side as well. All right, our next figure we're looking at is a triangle. That's one we work with quite a bit. And to get the area of a triangle, there's two different formulas you'll see used. One of them says area equals 1/2 times the base times the height. Or another one is area equals base times height divided by 2. So you'll be able to decide which of those works best for you. I would recommend writing both down right now. The next shape we'll be seeing quite a bit is the trapezoid. All right, now the trapezoid is similar to a parallelogram that you're going to see some parallel bases, but on a trapezoid you have one pair of parallel bases, whereas if you look back at our parallelogram, you've got one set there and a set there, so two pair of parallel bases. That's going to be the difference between those two. All right, so for a trapezoid, we're going to identify what our two bases are. Doesn't matter which one you call base 1 or base 2, but to get the area, you're doing base 1 plus base 2. So you're adding those two bases together and then dividing it by 2 and multiplying it by the height. Now, sometimes you'll also see it written this way. Area equals 1/2 B1 plus B2 times height. And again, you can decide which of those you prefer. Either one is acceptable. And then finally, we have a circle, which we now know to find the area of a circle. Our formula is pi times the radius squared. And we will generally be asked to round pi to 3.14. So you may also see a equals 3.14 times the radius squared. All right, so make sure you've got these down because we're going to be using these quite a bit on the next few slides. Our first example of a composite figure is shown on the bottom of page 467. And when you look at these, you're really just looking to figure out what figures do you see in there that you know how to find the area of. So when I'm looking at this one, I see a rectangle that stands out to me right away, or a parallelogram. And then above it, I see a trapezoid right there. So if I knew some of those dimensions, I could find the area of that composite figure by decomposing it into a trapezoid and a rectangle. All right, let's walk through our first example on page 468. So Ayana is painting a sign made from a piece of reclaimed wood with the dimensions shown. We're looking to find the area of the sign. The first step is we need to decompose the figure into smaller figures. And so when I look at this, I see we have a rectangle right here, and I see a triangle right there. And so they listed that out. It's composed of a rectangle and a triangle. And the second step we need to do is find the area of each of those figures. So the area of a triangle is going to be, the area of a rectangle is going to be the length times the width. And so if I'm looking at this one, we're going to call it 14.5 times 4, and we're getting that right here in our picture. And so when we do 14.5 times 4, we get 58. Let's write this here in red. 58. I'm not going to put a label on till the end. It is square inches, but you don't have to do that. I also like to put that right up in my picture. That's 58 square inches right there. Then I need to find the area of that triangle. And so I've got this guy right here. All right, and so if I'm looking at it, I kind of turn it sideways because this right here is going to be my base, and my height is the distance between them. All right, so my base is going to be the same as this 4 over on the left-hand side. So that's where we've got 4 from. So 1/2 times the base. And then the height of 6.25 came from taking this total length up here, 20.75, minus the 14.5 that was down here. And when you do that, you'll see that this amount that's left is that 6.25. That's where they got that number from. And then that is the same as the height of our triangle. All right, so then we do 1/2 times 4 times 6.25, and we get 12.5 as the area of our triangle. I'm going to put that up here too. All right, so then when we want to find our area of this composite figure, we just need to add those together. So we take 58 plus 12.5, and we get 70.5. So the area of this composite figure is 70.5 square inches. All right, let's give another one a shot here on the bottom of page 468. Find the area of the figure, use 3.14 for pi, and round to the nearest hundredth, 2 decimal places, if necessary. All right, let's start with our semicircle, which is what I see up here. It's half of a circle, right? And then below that, we've got a rectangle. So I'm going to call this A. Just kind of helps me keep track of my work. So my semicircle, I'm going to go area equals pi r squared. That would be the circle, but since it's half of a circle, we have to take that and divide it by 2. So there's the formula for a semicircle. All right, so let's calculate this. The area is 3.14 times our radius squared. Well, if our diameter is 1.5, right, that's what's given as the distance across the whole thing, then our radius has to be half of that, which is 0.75, and we're going to square that and then divide by 2. So be careful as you type this into your calculator. I'm going to go 0.75 squared times 3.14 equals, and then divide by 2. And you're going to get a decimal that looks like this. And I'm not going to round yet. I'm going to hold off till the end to do any rounding. So I have 0.883125. All right, so that's going to be the area of my section A, which is my semicircle. Then I'm going to work on this one next. What shape do you guys see here in my section B? If you said a rectangle, you'd be correct. And so I'm going to say the area of my rectangle is length times width, or again, base times height, you decide. And so my length here is going to be, or my base here is going to be 1.5 feet. And now I got that from straight up above, right? That was also the diameter of our circle. And so area equals 1.5 times 2.25. And we get an area of 3.375. Okay, so then to get our total area, we have to take those to an atom because we've got our semicircle added to our rectangle. And so I'm going to do that over here. I have 3.375 plus 0.883. I'm going to stop there. Since our final answer will be rounded to the hundredths, I can go 8, 15, 12, and I get 4.258. Telling me now to round to the nearest hundredth is going to be 4.26 square feet for our final area. 4.26 square feet. All right, now I'd like you to try one. Now this one's not in your textbook, so I'd just like you to sketch it out either on the bottom left of page 468 or over on the bottom right of page 469 under the pause and reflect. So take a minute to just kind of sketch out this picture and then try to find the area of the two shapes that you see in here. I see a trapezoid and I see a rectangle. Can you find the area of each of those and then find the area of this whole composite figure? Pause, try it out on your own, and then push play when you're ready to check. All right, the first shape that I started with was my trapezoid, and so you'll see this is the trapezoid here. I labeled it figure A. The formula is base 1 plus base 2 divided by 2 times the height. And then I see this square over here, and I know it's a square because this is 20 inches and that's 20 inches. And so it's just area equals base times height. Now that I've got my formulas, I'm going to plug in the values of each of those dimensions. For this trapezoid, it's a little tricky because I've got to find some dimensions that aren't labeled. So I've got area equals, now base 1, I'm just going to use this one over here, 13. Plus base 2 is going to be this longer base for me. And that is going to be the exact same size as this side of my square. So if that was 20, then I'm also going to label this 20 inches. All right, so 13 plus 20, that's my two bases added together, divide by 2. And now for my height, it's going to be over here. And I can find that length because up top, this is 20 inches and that's 20 inches. And we know this whole thing is 25. So this just has to be 5 inches here since this is 20. All right, so I have 13 plus 20 divided by 2 times my height, which is 5. And then we're just going to grab the calculator and type away. So I've got 13 plus 20, that's 33, divided by 2 times 5. If I take 33 divided by 2, I get 16.5 times 5. And that leaves me with an area of 82.5 for the trapezoid. I always like to kind of double underline it so it stands out. And then our square, this one's nice and easy. I just have a 20 by 20 square here. So the area is 20 times 20, which is 400. And now to get my total area, I'm just going to add those two together since this is a trapezoid with an area of 82.5 square units or square inches. And a square with an area of 400 square inches. I add those together for a grand total of 482.5 square inches for the area of that composite shape. All right, now it's your turn to practice. Please make sure that you've got your formulas nearby. You're going to use these as you're working today. If you have any questions, check in with your teacher. Thanks for watching.